Okay, so today let me share we are going to solve a lead code problem for binary search. So what I can see the problem is lead code 704 binary search given an array of integers names which is sorted in ascending order and an integer target. What our task is to write a function to search target in nums. If target exists, then we have to return its index. Otherwise, we need to return its -1. We must write the algorithm in order and log n complexity. So here we are simply given a simple non-decreasing or ascending order array, and target is 9. So you can see generally the approach for binary search is to divide the entire array in two parts. One is higher than the mid and another is the lower than the mid. So first we need to split it in two halves using a mid. So how can we find the mid? Mid is simply we can see the lower and higher and then divided by 2 we can subtract, and basically if we could see for odd it would be the mid element, odd size array, and if it is even size array there would be two mids. So we need to work on that. The algorithm will handle that scenario also. So yeah, let's go and look into this code. We will try to code. Actually this code I was writing before going live onto this. So let's see public and search it nums and target this method. Actually we were given, I am a Java coder, so here basically I'm going with Java. So let's start. Let's somewhere let's start with two variables. One is lower or left and one is right. We have initiated with 0 and right to get nums dot length. Now what we need to do, we need to figure out where is the target. Will it lie on the left side of the mid or to the right side of the mid? So what I did is let's iterate through the entire array while L is less than R. Somewhere we need to handle the movement of L and R. Okay, like L plus plus or R minus minus, something like that. We need to handle it later. So yeah, while going through each loop we need to look for calculate for mid. So we are calculating here mid is equal to L lower index plus R minus L divided by 2, so that we cannot avoid, basically to avoid array index of bound. Array index of bound index out of bound array. Okay, array index out of bound or something like that. Oh, okay, so here we have calculated mid. Okay, and now we need to see if we found our target. If nums mid is equal to target, voila, we so I think in that case we have found our target. And otherwise there are two scenarios. One is like if the target falls to the left of the mid or to the right of the mid. Okay, so if the target falls to the right to the left of the mid, then what we have to do, we have to traverse to the left side of the mid. So what part of the array will we are left with? We are left with an array which has a length from L to mid minus 1. So what we have to do is equal simply right, we need to update the right to right is equal to mid minus 1, and L plus plus. Okay. And now let's go for the second scenario. The second scenario is suppose the target falls to the right side of the mid. In that case, we need to update our left. We need to go to the other half, which is greater than mid. So left side would be updated. The index of the left would be mid plus 1. And right side should be subtracted. So we can do r minus minus. Okay. I think this should be sufficient for our binary search. This is actually binary search. Okay. Somewhere this method is need to be wrapped in a binary search. So let's extract it somewhere. Command X. We can't binary search into nums and in target. So all values simply the same method, but what I want to do is here we are returning the mid, so it will always happen. And the edge case is like if if we are not able to find the values the target inside the array, then we need to return -1. So let's return that inside our method. So return -1. Okay, let's call this method from here, which is return binary search nums and target. Okay. Let's run and see if this is working. Which case is
Hello, Moto.
1 minute. Okay, so let's go to our problem where we were. So somewhere I have made mistake. What mistake I have made? Here it is saying for -1 target is 9, then output should be -1. Why 9 is there? Why it is saying target is 9 and it is already there? Okay. Oh. Actually, this is for non-negative numbers. For all non-negative numbers. This algorithm works for this algorithm works for all non-negative numbers. Here. Let's see here what we have. Let's go and iterate one by one. For negative number, which is here negative number -1, it's iterate one by one. Suppose here L is equal to 0, L is at here, R is here. Okay. minus 1 and 12, while L is less than R, while L is less than R. Okay, 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 okay. Uh, 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 uh. Okay, okay, okay. Let me see if this is the scenario for actually 336. Somewhere I'm making a mistake. Let's go to R minus 1. Okay, minus 1 L, which is 0 plus R minus L, and again it is 1, 2, 3, 4, 5, 6. So 5 minus 0, which is 5, divided by 2, which is 2. 2 plus 0 is 2. 0, 1, 2. So made it 3. If nums made, which is nums made, which is 3, is equal to target, no, it is not equal to 9, then we need to see which half it is going. If target is less than nums made, if target which is 9 is less than nums made, no, it is not. Nums made is 3, and it is not less than, target is not less than mid, which is 3. Okay, so the target would lie into the other half, so it will skip this if and it will return to this. L is equal to mid plus 1. L is equal to mid plus 1, so L would be here 5. Okay, 5, and R would be R would not be minus minus. Mid plus 1. Okay. This I think it was missing. Okay, so you can see what both the cases are passed. Basically it is accepted. Now let me submit this. Okay, so here which I have written like this algorithm was for all non-negative numbers. Actually it was for all the numbers, whether negative or positive, but this would be ascending. Okay, so let me remove this line actually because it was for all. So we have a binary search method here, which is kind of let me see if not able to do this. Okay, so it should work, right? Oh yes. So basically what we need to do is we need to understand how binary search works, and we should remember it actually because this is kind of very basic, since while in maths we remember 1 2 3 4 something like that, while going through the solving data structure questions I think somewhere I had read that we need to practice a lot and we should remember these basics. These are like 1 2 3 of maths. Actually algorithm for 1 2 3 of maths is like binary search and then other searches. Then we should remember it to solve other hard or medium level questions. This would be very easy for us. This would make very easy for us if we remember these, or we can practice this maybe after week 5 week. So yeah, let's see where it goes. Okay, so that's all. We will see you. We will meet in some more other video. So I'm stopping sharing and ending the stream.